Hello everyone, I am Shivam Jagtap and today I am going to explain parallel database system. Parallel database. Why use parallel database? The ideal database machine should be a single infinitely fast processor with an infinite memory with infinite bandwidth and it would be infinite cheap. But do we have such an ideal machines? No. So the challenge is to build an infinitely fast processor out of infinitely many processor of finite speed and to build an infinite large memory with infinite memory bandwidth from infinitely many storage units of finite speed. Answer to this challenge is parallel database. Introduction. Parallel machines are becoming quite common and affordable. Price of microprocessors, memories and disks have dropped sharply. Databases are growing increasingly large. Large volume of transaction data are collected and stored for lateral analysis. Multimedia objects like images are increasingly stored in database. Large-scale parallel database systems increasingly used for storing large volume of data, processing time-consuming decision support queries, and providing high throughput for transaction queries. Parallelism in database. Data can be partitioned across multiple disks of parallel input-out, and individual rational operations can be executed in parallel. Data can be partitioned in each processor can work independently on its own partition. Queries are expressed in high-level language such as SQL translated to a relational to algebra, make parallelism easier. Different queries can be run in parallel with each other. Concurrently controlled takes care of conflicts. Thus, database naturally leads to themselves to parallelism. There are mainly four types of parallel database architecture: shared memory, shared disk, shared nothing, and hierarchical. Now, which is discuss each shared memory, extremely efficient communication between processors. Downside is not scalable beyond 32 or 64 processor widely used for lower degree parallelism. Shared disk. Example IBM Simplex and DCS cluster. Downside bottleneck at interconnection to the disk subsystem. Shared disk subsystem can scale to a somewhat large number of processors, but communication between processors is slower. Shared nothing. Example Teradata, Tandem, Oracle, NQ. Data from local disks do not pass through interconnection network, thereby minimizing the interface of resource sharing. Shared nothing multiprocessor can be scaled up to thousands of processors without interference. Main drawback cost of communication and non-local disk access. Sending data involves software interaction at both ends. Hierarchical combines characters of shared memory, shared disk, and shared nothing architecture. Parallel database issues, data partition and parallel query processing. Parallelism, horizontal partitioning. Types of relational are divided among many disks such as that each tuple resides on one disk. Partition technique, round robin, hash partition, range partition. Skew, the distribution of tuples of disks may be skewed. Attribute value skew. Some value appear in the partition attributes of many tuples. Partition skew. Too many tuples to some partition and too few to other. Round robin handles skew well. Hashing and ranging may result in skew. Typical database query types: sequential scan, points query, and range query. Comparison of partition technique: round robin, hashing, range. Handling skew using histogram. There is a diagram which explains the frequency value graph. Intra-query parallelism, execution of a single query in parallel on multiple processors. This speed up long duration queries. Two complementary forms of intra-query parallelism are intra-operation parallelism, parallelism that includes exclusion of each individual operation in the query. Intra-parallelism, execute the different operation in a query expression in parallel. Thank you.